Protocol Daemons. The daemons, or Unix background processes that run on the Junos operating system routing engine, perform a number of management, control, and processing functions. Let's have a look at the routing protocol daemon. The routing protocol daemon is essential to the functionality of the routing engine in the Junos operating system. It feeds intelligence to the router, and for all intents and purposes, controls the forwarding of packets. One interesting thing about the routing protocol daemon is that it resides in user space, not the kernel. Each process runs in its own protected memory space, and the kernel manages communications between them. It's done this way so that a single process failure won't bring down the entire system. In the Junos operating system, the routing protocol daemon is allocated a lot of memory. It's common for a process like the routing protocol daemon to consume a lot of memory. For the sake of performance, and with all that the routing protocol daemon has to do, it's necessary to have it architected this way. Components used by the routing protocol daemon include routing protocols, routing table, and the kernel routing table. Routing protocols. The routing protocol daemon applies routing protocols and decides what it determines are the best routes. These are then recorded as the active routes in the routing table in the kernel. The routing protocol daemon also uses routing protocols to maintain the forwarding table, and then it provides a copy to the packet forwarding engine. Of course, there are multiple protocols, and these protocols are placed in the kernel, and the packet forwarding engine selects the appropriate protocol to use. Now let's talk about some of the routing protocols supported by the Junos operating system. Routing Information Protocol, or RIP, is a common interior gateway protocol for managing and sharing routing information within small homogeneous networks, like, for example, a corporate LAN. To determine network source to destination distance, RIP uses the pretty simple metric of router hops. It's somewhat effective for the purpose that RIP serves, but it has mostly been replaced by Open Shortest Path First, or OSPF. OSPF is another interior gateway protocol. So what happens here is that when a change to the routing table or network configuration is detected by a router, it multicasts this change to all other OSPF hosts that reside on the network. That way, all routers on the network have routing tables that are in sync, and that's a good thing. It also uses a slightly more sophisticated algorithm to determine network distance, basing it on link states and not just hop count. Intermediate system to intermediate system is a very popular protocol. Like OSPF, IS to IS uses link state as a way to determine the best route. Information about the state of a link is stored. Then that information is used to select routes. IS to IS protocol is applied to occasionally broadcast link state information across a network. This way, each router on the network has an up-to-date picture of the network. Again, that's a good thing. Some of the information that can be used to determine link state includes network delay, some metric to measure expense, and error. Border Gateway Protocol, or BGP, is used to exchange routing information amongst gateway hosts in a network of routing domains. It's quite common to see BGP used amongst gateway hosts on the Internet. Hosts in this scenario use TCP to send updated router table data in the event that one of the routers detects some change, and only the affected pieces of the routing table get sent, so it's pretty efficient. Other notable protocols include Protocol Independent Multicast, or PIM, IPv6, and there are other protocols supported as well, but for now, that gives you a good idea of how the routing protocol daemon works. So, in this video, you had a look at the Junos operating system protocol daemons.